Hello, this is a video about 9 best practices for passing a college level calculus course. A lot of colleges use the first 2 years of calculus as weed out courses, basically for engineering programs or science programs. The dropout rate is pretty high, and I don't think that it needs to be as high as it is. And if you have a basic understanding going in to the class about what are the expectations, good organizational structure, good principles, then hopefully that'll help you achieve a better grade and get through both calculus classes. So here's 9 of them. The first one is, remember, it's a language. Think of this course as you're speaking a language. You learn the language and you speak the language. Practice speaking like your professors or your TAs. Listen to the words they use. And obviously, if you're in class and they're using a word, either look it up in your textbook, look it up online, or just ask them. Know the notation that they're using. The notation that they're using has been there for a lot of years. I look back 30 years ago when I took calculus in college, and the notation is exactly the same now that I'm tutoring my son. And so, let's see, and when you're asked to explain something on homework or on tests, you must use that proper notation or that language, or else they're just going to assume you don't really know what you're talking about. Or you'll just get partial credit. So, and also, if you know the language, you'll know what they're asking for on the exams. It's very important. That's the most important thing. And at the end there, I just say, think of it as grammar is to an editor as process and language is to a mathematician. All right, next is the course is about methods, theorems, and rules, not just correct answers. It's the difference between solutions and answers. In math, 2 wrongs can make 2 wrongs, basically. And if you're saying to yourself, well, I can just execute the derivative in my head and get the answer, well, then you're not going to get all the points you need on the test, and you need to get A's and B's on the exams. And so remember that the math department makes those exams, they set the goals for the course, and it is about methods, theorems, and rules. So show your process when you're handing in your homework and tests. All right, have a consistent organizational structure. I think this is probably one of the most important things if you walk away from this. Is it's okay to be that guy, neat and organized, and you're already in calculus. You're not trying to prove how smart you are, that you can do stuff without doing the work behind it. You're trying to show that you can do that work. If you think of it more like when you were back in geometry class and doing a proof, and you had a table and steps, that's a good organizational structure to stick to. And your grader will thank you at the end of the day. So swallow your pride. Here's just an example of where I put on the left column the steps, and then the right column the reason. So that'll be really helpful when it comes to explain your answer problems. Okay, always use scratch paper. Now you're usually allowed to have scratch paper with tests. So, and then you are usually just given a quarter of a page to do the problems on. So just forget about trying to do the problem in that quarter of a page and just go straight to your scratch paper for everything. Obviously, there's going to be some exceptions to that, true and false and whatever. But if you need to show your work, use that scratch paper. And just assume that the space they give you is not going to be enough. And then be neat on your scratch paper with clearly numbered problems. This is problem number 1, this is problem number 2, or just use one side of your scratch paper per problem. And because paper is cheap, and it's a lot cheaper than retaking calculus in another semester and adding another semester onto your curriculum. Okay, always state the obvious, number 5. You're taking a calculus course. You're not trying to prove that you're smarter than the course content. You're trying to I tell my son, act like when you're doing on a test or doing your homework, that you're almost trying to teach somebody else how to do the problem. You're trying to show somebody else how to do the problem. So be smart and state the stupid, simple things that you inherently knew. And so the graders are, when they're grading your tests, are looking for keywords or demonstration of principles. So they want to see that you understand it. They're on your side too. They want to give you a good grade. So partial credit is definitely your friend. All right, so no matter how obvious the theorems, number 6, know its name. There's things like the squeeze theorem, the mid-value theorem, all these little things, when you pull them apart, seem painfully obvious. But if you know their name, it'll be so much easier for you to explain it on your test, or when you're doing the organizational structure that I recommended in step number 3, then you can put it on the right-hand column. I use squeeze theorem here, or mean value theorem. And so if you know the name, it'll be so much easier for you on the test to explain what you're doing. And again, think of it like in your geometry class. The theorems in geometry class were used during your proofs. This should be exactly the same thing. All right. Number 7, think literally when reading your directions. Now, the math department creates your tests, and they probably create your homeworks as well. If you're in the middle of a test and you read the directions and you think, that can't be right, it probably is. So think of it literally. Do your best there. And ultimately, if you do have a question and you were able to ask, do so, and ask the question in a manner that they can actually answer, because they're going to be very tight-lipped about how they answer stuff in the middle of a test. And so formulas are the formulas, even when they seem stupid rather. They are leading in the wrong direction. And this happens with positives and negatives and things like that. So this isn't engineering class, this is math. So if you can trust the formulas, then trust the formulas. See, and I put in the bottom, that can't be right. Well, it usually is right. So, all right, number 8, look ahead in your syllabus. If you know you're going to be working on chain rule next class, take a few minutes to go look up a YouTube video, look up Google it, look in your textbook, anything to kind of prime your brain and get it ready so that you can get through that first 15, 20 minutes of your class and still understand what your professor is saying. Just prime your brain, get it thinking in that right direction. And if you get it right, then you're essentially giving yourself a little bit of a gift every week of that. You're getting back that hour in class as productive time rather than confused time that you have to go back and try to understand later. So anyway, and your professors will tell you this on the first day of class too. And so it's good advice. All right, number 9, lastly, the tests are timed, so practice doing timed tests. Of course, you need to work through the problems and get them correct first, but do them several times over and over again, the same types of problems, so your brain can move quickly through getting through the process. So if you have old exams from previous years that are posted online and the university is giving that to you, please go back, find them and use them. And so math departments do want you to pass, but you have to get things right and demonstrate that you know the content. So, and if you are at a university that does not post their old exams, you can look at universities that do post their old exams and use their tests as practice tests, because the syllabus that each university uses are going to be very much the same. They're going to follow pretty much the same order. They might even be using the same textbook. But the bottom line is calculus is not easy. You have to practice it. You have to know the nuance of it. So I think lots of people get caught in a false sense of security as they're studying for their tests. It seems like, oh, I've got this. I've got chain rule. I've got that. I seem to understand it. Well, they're going to come back and they're going to get you with the fundamentals of things. And so if you can know things all the way back to there, you'll be far better off. So anyway, so I just relisted what each of my recommendations are, my best practices. Bottom line is good luck, study hard, don't take anything for granted. Remember its process and language. Have that consistent organizational structure. It'll help you remember to write down things and help you get that partial credit. So state the obvious, look ahead of your syllabus, and practice. Anyway, good luck. I'll be posting actual technical videos here. So look out for those, subscribe to the channel, and hopefully we can get some stuff together that really helps, especially engineers, get through calculus. Thanks. Talk to you later.